Our block set up in our grinder, we put it back in the pressure washer, took all the metal shavings out, took all that WD-40 out. That way we keep our coolant as clean as possible. So I already got the machine set up. I got the block squared in with the machine. I got 3 points of anchors, or 3 points of tie down on this block to make it stable on the machine. So now we're ready to start machine. The next thing we're going to do is we're going to polish the journals on the crankshaft. We're going to be working on the mains and the rods. We already got it set up on the machine to polish the rods. Adam's pressing out the old pistons, getting the rods ready for a new assembly. Alright guys, so you saw us last, we were polishing our crankshaft. We got our block pretty much cleaned up, ready for installation. So next thing we want to do is we want to check the journal diameter. A lot of people like to use plastic gauge. I came from, when I did my apprenticeship, we didn't use plastic gauge because it's a very generic tool. I mean, it does work, don't get me wrong. That it only works if the journals are perfectly round, because you only measure from one side. You're not measuring the whole radius of the whole diameter of the crankshaft journal. So if you were to use a plastic gauge and the journal has an egg shape, it might read that it has a proper clearance on one side, but then when it rotates 180 degrees, 90 degrees, it could be off. So that's why we don't use a plastic gauge. We actually measure the journals and we find the specs for the crankshaft diameter in a book. So let's see if we can get it to zoom in. I'll just read it to you. So, yeah. Oh, sorry guys. Sorry. So, for our main bearing journals, the low end is 54.943 and the high end is 54.955. So meaning the low end, that's the lowest amount, that's the smallest the diameter can be within still being in specs, and the highest is 54.955, and that means that's the biggest it can be without running into oil clearance issues. So for standard stuff, you don't really have to worry about it. Mainly when you're getting your crankshaft resized, this is very important because you want to make sure that your crankshaft grinder kept everything within specs. Usually the crankshaft grinder always aims for the high end to keep the oil pressure high and to keep the tolerance high, and also that way that if they were to rebuild it later on, they can polish the crank and it'll still be good. So we did polish the crank, right? You saw us last, we were polishing the crank, so our journals are nice and cleaned up. So the next thing that I did already, but that you would do is you would want to get a micrometer, a good micrometer, and check your journals. So the way you would check would be, so I'm going to come around this way. You want to check the different spots, and you would want to wiggle it. So I'm getting 54.95, 54.95, 54.95. Check the top as well. 54.95. 54.95. So when you're using your micrometer, it was the same thing as when we did the bore gauge. You want to square up your micrometer. You want to make sure that it doesn't go at an angle, because if it goes at an angle, what's going to happen? It's going to make it bigger. If it goes at another angle, it's going to make it bigger. So when you're trying to get your reading, you want to get the smallest number. And the smallest number is going to mean that it's perfectly squared up. But you don't. Another thing that you don't want to do is you don't want to force your micrometer, because you're talking about such small. We're dealing with fractions of the thickness of a piece of paper, guys. That's the tolerances that we're dealing with. A sheet of paper is about 4/1000ths of an inch. And right here, we're dealing with about 2/1000ths. So we're dealing with half the thickness of a piece of paper. And that's the other thing. When you're moving it, you want to get that proper reading. That way you know you did everything correct and it's all within specs. Because if you're off just a little bit, that could be an extra thousands. Especially if you're trying to cut it close with the low end. You want to make sure that you're still within range. So we checked all our mains. We checked all our rod journals. Everything's still within spec. We went through the book. We got our measurements from the book. We have our crankshaft on our stand. and we went through everything. So next thing we're going to do is we're going to actually install it into the block. So we got our block already prepared, we got it cleaned, we got it board, we got it decked. The next thing we do is all the journals. We want to make sure that they're all clean, there's no rust. If there's rust, what that does is it pushes the bearing up into the excuse me, it pushes the bearing up into the crankshaft journals, which will cause premature bearing failure. And that's another thing that you have to be very careful, that all the channels from the block are clean, they don't have any rust, they don't have any dings in them, especially because we use the boring bar, and the boring bar connects to the mains. So we had to make sure that that boring bar that clamp, that anchor base didn't mess up any of our mains, so that way our bearings have the proper clearance. And we're gonna just put a little bit of assembly lube. This is the Lucas assembly lube, semi-synthetic. And it's good to have semi-synthetic because you want soft metals in your assembly lube. Those soft metals will allow for a proper break-in. So another thing we want to make sure is that the crank spins nice and freely. If it doesn't spin nice and freely, that means that it's binding somewhere. It could either be binding on your thrust washer setup, or it could be that the bearings themselves, the bottom side of it isn't clean, causing it to be offset. So our crankshaft spins nice and freely. We got a good layer of assembly lube on our journals. And that's all you really need. You don't need a whole, I see people squeezing and then it comes out from the sides, you're making a mess. When you're building a lot of engine blocks, you use it more sparingly. I guess a lot of people that don't really build engines have a lot of assembly lube to waste, but I go through it pretty fast, so I try to be more strategic as I use it. So next thing I'm going to do is I'm going to start putting the caps in, getting all that set up. Okay, so we got our caps all nice and clean. Like I said before, it's really important that we get this bottom side clean. Another thing that's really important is to make sure that these faces are clean. And one trick that you can do is when you're on the minimum side of the rod journals is just sand these down a little bit. So you'll sand these down a little bit, and that'll help to get you proper clearance again. But you don't want to go too much. It's just a little bit. You'll go about 3 or 4 times on a sheet of sandpaper, about 150 grit, and from there, it's just a little bit more prep work that you're going to do to get these caps ready. And so now what we're going to do is we're going to install the top sides of the bearings. So our bearings, as you see, for mains, they have 2 faces. The side with the hole always goes on the block. Sometimes you get dummy bearings that have the same face on both ends, but you want to make sure, usually there's a top and there's a bottom. So this side that's flat, no holes, no groove, this is going to go on our caps, and then this side with the groove and the hole, that's going to go on our block. And what that hole does is that feeds oil into the crankshaft. From there, from the main journal, it goes to the rod journal. So that's why you need to have these set up properly, or else you'll have oil pressure issues or lubrication issues.